All right, so this one's going to be pretty short. This is the beginning of chapter 3, chemical reactions and quantities. By the end of this chapter, you're going to be able to, if I tell you I'm giving you this much stuff to react, you should be able to tell me how much stuff I'm going to make to produce when I do a reaction. That's kind of the most important part of chemistry is if I put these things together, what can I make and how much can I make and what are its properties, right? So talking about chemical equations. So what is a chemical equation? A chemical equation is something in chemistry that one describes a chemical reaction. So it kind of tells me what's going on with the chemicals, the molecules, the atoms, the bonds, that type of thing. It's going to involve some type of rearrangement of atoms to make different bonds and such. So it's going to rearrange the atoms. So now I get different molecules. That's all a chemical reaction is. So it breaks bonds, makes new ones, I get different molecules. Okay, fundamental principle for chemical equations is the law of conservation of mass or matter or whatever you want to call it. But things can't be created or destroyed, right? If I start with this many atoms, I also have to end with this many atoms. And that's something very important to remember. So atoms cannot be created or destroyed. Okay, they can only be rearranged when we're doing chemical reactions. So this is a chemical equation. I'm going to kind of break it down. We're going to use a lot of chemical equations this year. So there's some terms that you need to know. So first of all, anything on the left side of the arrow is considered a reactant. Anything on the right side is considered a product. Okay. Other things we need to pay attention to. Coefficient is what this is called. This is a coefficient, a number that's in the front. Okay, the little numbers, we've kind of already talked about these a little bit, are called subscripts. Okay, and these little letters in parentheses here tell you the states of matter. So you can be solid or liquid or gaseous, or the other one I'm going to add is aqueous, which means it's dissolved in water. Okay, so those are the states. The subscripts tell us how many atoms are in that molecule, and the coefficient tells us how many of the molecules. So coefficient, let's see, it tells me the number of those molecules in the reaction. In a reaction. I abbreviate reaction RXN, just so you know. So this means I have two H2 molecules. Okay, so two things that are H2s. That's what that means. The subscript tells you the number of atoms in that molecule. Okay, so each hydrogen molecule is two hydrogens bonded together. Each oxygen molecule is two oxygens bonded together. And then over here, I have two waters. A water molecule is two hydrogens and an oxygen all bonded together. Okay, so when we are balancing equations, it is important to note, that's why I put this in all caps, that the subscripts cannot be changed. Okay, O2 is oxygen, always. If I change it to O3, I made a completely different molecule. O3 is ozone, it has completely different properties. Okay, water is H2O. If I try to change the little subscripts, I actually change the molecule. If I do H2O2, when I'm trying to balance it, I can't do that because I made a totally different molecule. H2O2 is hydrogen peroxide. Okay, so you have to, when you are balancing, don't change the subscripts. The subscripts are based on the names. They're based on balancing those charges that we talked about in the last unit. So don't change the subscripts when you're balancing. You're going to balance by adding or changing coefficients. Okay, so there's a method to the madness. Unfortunately, most people like to say it's kind of a guess and check. Essentially what you're doing is you're figuring out by inspection and then checking it and checking it. Okay, so double check that all of your atoms add up to one side and the other side. Okay, the other thing is you're going to, I would anyway, use a tally to kind of keep track of how many of each element you have. Use tally for each side. And because you should have the same number of atoms on one side as you do on the other side. And you want to start with elements that occur once on each side. So like the reactant side and the product side. that'll kind of make it easier. So I have a couple of more tips. If you've got polyatomic ions, do those first. Do polyatomics first, as long as they stay together anyway. If it's a combustion reaction, so something that makes carbon dioxide and oxygen, do C and then H and then oxygen. It'll kind of help. Also with combustion reactions, if it's not balancing and you keep getting this even odd thing, try to double the complicated molecule or the hydrocarbon. Complicated molecule if needed. And my last one is to do pure elements last. So balance pure elements last. Okay. So essentially, you want everything on the left side to equal everything on the right side. So if I'm looking at this reaction, I'm going to make a line, and my two elements are aluminum and chlorine. I got aluminum and chlorine. So what I say when I mean tallies is right now I have one aluminum and I have two chlorines. Over here I have one aluminum and I have three chlorines. Well, my chlorines are not balanced. And I know the least common multiple between 2 and 3 is going to be 6. So I'm actually going to need 3 Cl2s, because that means that I actually have 6 chlorines, 3, 4, 5, 6. And then I'm going to need 2 of these, but that now makes it so I have 2 aluminums and 4, 5, 6 chlorines. So my chlorines are good, but now I got 2 aluminums. So I'm going to have to put a 2 here so they balance out. So that's what I mean by the tally marks. You might be able to do it just by looking at it. Okay. Balancing this reaction, I've got H3PO3, H3PO4, and PH3. Now, remember, one of the tips was if you have an element that's only in one molecule on each side, do that one first. So I'm actually going to do oxygen first. 3 and 4. The only way to get 3 and 4 to balance is to get them both up to 12. So I already know I'm going to have to put at least a 3 and a 4 there. Now my oxygens are fine because 3 times 4 is 12. 4 times 3 is 12. My oxygens are good. Okay, from there, I should look at my hydrogens and my phosphoruses. So I have 12 hydrogens here. I have 3 times 3 is 9 hydrogens here. And I got 3 more over here, and that's 12. And then I have 4 phosphoruses, and I have 3 phosphoruses here and 1 here. Okay, so the way these coefficients work is it gets distributed to the whole molecule because it's like I have 4 of these molecules, just like a coefficient in math. All right, so try to balance these equations and then check your answers. All right, these are what I got. Notice I didn't write a 1 if I only need 1 of something. The 1 is understood. And like that doubling thing I talked about. So down here in this combustion reaction, I had to end up doubling the big molecule and then rebalancing to figure out how to balance best.